Space is not big. Space is ridiculously big. If Mars were a short road trip, the nearest star is a multi-thousand-year road trip, at the fastest speed humans have ever achieved. So every sci-fi universe faces the same daunting question. How do you cross interstellar distances without waiting until your descendants are dust? Some stories describe extreme speed. Some alter dimensions. Some use portals. And Dune? Dune manipulates reality itself, and then hires a spice-mutated prophet to make sure the manipulation doesn't turn you into plasma. In this episode, we're ranking the most famous faster-than-light systems, comparing them to the Holtzman drive, and judging which ones are closest to science and which ones are basically wizardry posing as technology. Before we start throwing ships' comparative drives across galaxies like darts, one rule. We're ranking scientific accuracy by how little each system has to violate what modern physics currently says. So we'll ask 3 questions. 1. Does it require negative energy or exotic matter? 2. Does it allow time travel or causality breaks by default? 3. Does it ignore the hardest part, navigation, like it's a trivial menu choice instead of life or death math? And because Dune's Holtzman drive is our baseline, we'll keep asking, is it moving the ship or moving space-time? And who's doing the math, computers or a human oracle? Battlestar Jump Drives are a flex. No long travel, no tunnel, no streaking stars, just flash, and you're somewhere else. That's closer to Holtzman than hyperspace is, because it's discontinuous. It's not travel, it's repositioning. But Battlestar's key twist is, you can jump to the wrong place. You can jump inside a planet. You can miscalculate and die. So navigation is life and death, which is Dune's whole point. Except in Battlestar, the solution is math plus computation. And in Dune, the solution is prescience plus spice. Scientifically, teleportation of macroscopic objects isn't a thing we can do, and instant relocation raises massive questions about energy, momentum, and causality. So jump drives land near the bottom. But narratively, they're incredible because they feel dangerous. And danger makes FTL interesting. Now we enter the fun zone. Star Wars Hyperspace is iconic. Stars stretch into lines. The ship whoops, and you're far across the galaxy in the time it takes to finish a dramatic sentence. But hyperspace isn't fast in normal space. It's a separate realm, a shortcut dimension with its own rules. And because it's a different medium, navigation becomes the real danger. You need precise routes. You can't just wing it. You can hit mass shadows and die horribly. Sound familiar? That's Holtzman's problem too. Navigation is everything. But here's the difference. In Star Wars, your solution is computers and nav charts. In Dune, computers are taboo. So the solution is a living oracle. Scientifically, hyperspace is basically another dimension with no rigorous grounding. Not impossible in a philosophical sense, but extremely underdefined in a physics sense. So it ranks lower, not because it's bad, because it's mythic. Star Wars isn't trying to be scientific, it's trying to be legend. Mass Effect does something clever. It admits FTL might not be a drive at all. It might be a network. Relays reduce the energy cost by making travel dependent on fixed points, a galactic highway system, rather than every ship being a god. Compare that to Dune. Dune has a monopoly because only the Guild can do it safely. Mass Effect has a monopoly because the infrastructure controls the lanes. Different choke point, same political outcome. Holtzman's empire is addicted to spice. Mass Effect's galaxy is addicted to relays. Scientifically, still speculative, but structurally, Mass Effect is one of the best politics of FTL systems ever made, and it rhymes with Dune beautifully. Next, the portal approach. Instead of moving faster than light, you create a shortcut. 2 distant points connected by a tunnel through spacetime. That's the wormhole fantasy. If warp is bend space, wormholes are fold space and punch a hole through the map. Sound familiar? Yes. Holtzman is a cousin of this idea, except wormholes are typically stable passages, while Holtzman is a chaotic jump where the universe might roll snake eyes. And wormholes have the same big red warning sign as warp. To keep them open and traversable, you likely need exotic matter or negative energy. So again, speculative, but within the mathematical playground of general relativity. Holtzman, by contrast, doesn't show the math. It shows the cost. The cost is navigators. Wormholes ask, can we engineer the tunnel? Holtzman asks, can a spice mutant see the safe timeline through chaos? Warp drive is the respectable one at the party. Because unlike hyperspace, it's trying to wear a lab coat. The basic idea? You don't move the ship faster than light. You move space-time around the ship. Space compresses in front, space expands behind, and the ship rides the distortion like a surfer on a cosmic wave. Compared to Holtzman? Holtzman, instant relocation by folding space. Warp, continuous motion through a warped bubble. Holtzman exists in 2 places at the same time, with consequences. Warp is a very polite attempt to loophole relativity. But warp has a problem. In most real-world versions, like the Alcubierre concept, you need exotic energy conditions we don't know how to generate or control at scale. So scientifically, warp is speculative, but it's at least speaking physics-flavored language. Rank it high, not because it's proven, but because it's trying to be consistent. First, before gates, before shortcuts, before alien miracles, you need an engine that stops space from being a death sentence. That's why the Epstein Drive wins. Because it doesn't make up physics to travel the universe. It simply takes the rules of motion and pushes them with heaps of speculation. This is not FTL. This is the closest thing to practical starship travel that still respects known physics. Most real sci-fi travel means this: high acceleration, relativistic effects, acceleration affects travel times, real consequences. And it changes everything. Mars isn't far anymore. The belt becomes reachable. Military power becomes thrust and projectiles, not magic. And travel becomes a brutal economics problem. Fuel, mass, heat, G-forces. The Epstein Drive is the most scientific winner because it keeps the cost real. You don't get to pretend much. If you accelerate too hard, humans die. If you run out of reaction mass, your ship becomes a coffin. If you misjudge a maneuver, Newton kills you without emotion. Now compare that to Holtzman. Holtzman says, distance is irrelevant. Epstein says, distance is a problem you solve with engineering, time, and suffering. Holtzman is a physics myth with a prophet at the wheel. Epstein is a physics reality with a human spine paying the price. And that's why it wins. But here's the twist. Even the best real engine in the universe can't make star-to-star travel practical. Not on human timescales. So now we reveal the main winner, the final payoff. Because if humanity ever reaches the stars quickly, it probably won't be because every ship has a miracle engine. It'll be because someone, something, built a doorway, a gate, a network. Not speed, just access. That's why the Ring Network wins the interstellar category. Because it feels like what the universe would allow if FTL exists at all. Not freedom, not infinite individual mobility. A corridor, a route, a bottleneck. And bottlenecks create the most compelling consequence of all. Politics becomes physics. Whoever controls the gate controls the economy. Trade routes become empires. Blockades become wars. And permission to travel becomes power. Now watch the mirror with Dune. Holtzman travel works because the math is too dangerous, so a spice-mutated navigator filters futures and chooses the survivable thread. The Ring Network works because the map itself is rewritten and everyone becomes dependent on the doorway. In Dune, the choke point is Spice, the Holtzman Drive, and the Highliner ship. In the Expanse, the choke point is the gate. One civilization is addicted to a desert drug. The other is addicted to a piece of infrastructure no one fully understands. And that, right there, is why both of these are the final payoff and the winners. So here's the truth that beats almost every flashy FTL button. The Epstein Drive is the most believable way to make a solar system livable. The Ring Network is the most believable way to make interstellar travel inevitable. One is the foundation, human engineering, paid for in blood and bone. The other is the payoff, a gate that turns the stars into borders. And compared to Holtzman? Holtzman is still the most mythic because it weaponizes dependency through prescience. But if you're asking what breaks physics the least while still changing civilization the most, the winners aren't the ones that go the fastest. They're the ones that create choke points. Because that's what the universe always does. It doesn't give you magic. It gives you a doorway and makes you fight over who gets to walk through it. All right, here's the list. Clean and brutal. And if you're thinking, wait, why is Holtzman last when it's the coolest? Because this ranking isn't coolest. It's closest to what we can justify with physics today. But in terms of storytelling, make no mistake, Holtzman is the ultimate masterpiece. Because it turns the FTL problem into religion, economics, addiction, evolution. and a permanent hostage situation, where the entire galaxy kneels before a desert. That isn't a drive. That's a brilliant plot device disguised as technology.